0. Okay, now, so now if you look at this equation again, you will appreciate a little bit more. You see that I can plot the delay of any logic gate, and it depends on the fan out. You see that if I have an inverter, G equal to 1, P equal to 1, right? So it has a 45-degree 9. You see that we always have some delay due to the intrinsic delay, right? We talked about that already. No matter how strong my arm are, I can lift the weight very easily. I always have a delay that need to lift up my very heavy arm, right? So that is the intrinsic delay. After that, you have this effort delay. They call it effort delay, right? You need to prove the real stuff. These are the real stuff you need to prove, right? If you are a LAN gate, you start with something, right? Maybe I'm just I mean, this car is just have larger overload, right? Maybe your you have more engines, so you're heavier when you try to carry something, and also it is more difficult for it to drive a larger fan out because of its logic gate effort. Okay, so here we define one thing you find very important. It's called G times F. Okay, which we call the gate effort H. Just a definition, right? So this can be confusing. If I were you, I will write in the cheat sheet, right? So don't get confused. Remind yourself, G times H, G times F is the gate effort. Okay, any questions? Now with this, then I can start playing with general logic gate train, right? Not just inverter. So it is the same. The total delay, of course, equals to summation for different stages from I to N, TP0. But now you know you may have different gates. So your P will be different. If it's inverter, it's 1. If it is LAN gate, it is 2-input LAN gate, it is 4/3, right? And then we also have the GI, different logic gates. You have different G, right? And of course, at different stages, you have different F, right? But we're using the same technology, so gamma is constant. Okay, now, so how do I minimize the delay? We just use the same method. To minimize it, you see that there's no choice for me to change the PI, right? I cannot change GI because these are the logical function. You are doing an adder, is adder. You can say that I want to make it faster. I change the LAN gate to an inverter, right? Then the function is wrong. Even you are fast, you're just faster to get a wrong answer, right? So P and G, I cannot change, right? So what I can change is the fan out again, right? So I will try to minimize TD by fan out, okay? Make it equals to 0. And again, you see that this fan out appear in a few places. Let's just do the derivative, right? So the first term has nothing to do with fan out. Okay, so when I do this one, I get what do I do? GI divided by gamma. Okay. Oh, did I do something wrong here? There's something got lost in my derivation. I'm sorry. Give me a minute. GI divided by gamma. So forgive me. I just copy my cheat sheet first, but I am not sure why I say that, right? So we do a partial derivation on Fi, right? And then we will get Gi plus 1, Fi plus 1 divided by gamma. I don't think this is correct. So I think I did something wrong on my cheat sheet, right? So let me say something. Yeah, of course we will depends on fan out, but I think we need to do it with the CI. I think I did it wrong in my cheat sheet, right? So just like what we did, this is TP0, right? This is PI plus GI, and then FI is CI plus 1 divided by gamma CI, right? So I do the differentiation. So the left term I get GI, right? And then CI plus 1 divided by gamma CI square minus, right? Because only two terms relevant, right? Here I only have TPO PI plus TP0 GI CI plus 1 divided by gamma CI. And then another term is P0 I plus 1. Actually, I plus I minus 1. This is actually should go earlier. TP0 GI CI gamma CI minus 1, right? Do you see what I mean? If I expand the summation, right, I have many terms. Only two terms have the CI, right? Only two terms have CI, right? Correct? And then I do the differentiation. So other terms become 0 when we do differentiation, right? And then now I'm trying to differentiate this one. And the first term gives me negative GI CI plus 1 gamma CI square. And then the second term gives me GI divided by gamma CI minus I, okay, which is equal to 0 because I need to set it to 0. This is plus I, right? Is that okay? Then the gamma is gone, right? And here I also say something about this should be GI minus 1, right? So this is GI minus 1, right? So by doing this, you see that this becomes GI minus 1 times CI divided by CI minus 1 equals to GI CI plus 1 divided by CI, which is GI minus 1 FI minus 1 equal to GI times FI. Okay, right? So sorry for that glitch, right? I did something wrong in my cheat sheet. So we actually cannot just do Fi, right? Or just a partial differentiation with respect to CI, okay, for FI, right? And only two terms will appear, will left. Then you just do the derivation exactly like we did for the inverter train, right? And then you arrange the term, you find that last time, remember what we said? Anyone remember how we minimize the inverter train? How should we size it? Do you remember? For inverter train. What is the criteria? Forgot?
All F should be the same.
All F should be the same. But here it tells you that no, this time it is all GF has to be the same. But we already say that GF is just H, right? It means we want to have the same gate effort here, H, right? Just a terminology, but more importantly, it's just saying that we want to have the same GF in each state, okay? And because of this, then we say we want to, then we say that we define H capital H equals to H1, H2, all the way to Hn. So we want H equal to, you take the nth root of capital H. And of course, this also equal to F1, G1, F2, G2, all the way to Fn, Gn. Okay? Or we can further define that this is equal to capital G times F. No, this is not capital G times F. I will discuss this later. Okay, so in summary, sorry for the glitch. You can go back to take a look again, but this is as simple as the inverter. It is that for every stage, we want to have the same GF or same H. Okay, any questions? Now, let me just write the summary, right? To minimize, right? We need same gate effort. That is HI equal to GI, FI equal to constant. This is the first thing. Okay. And we also define H equal to H1 all the way to Hn, multiply together. And we want the H equal to the nth root of capital H. If you have n stages. Okay, we also define something. The overall G equals to G1 times G2 all the way to Gn. Okay, but what is F? F is still the same. It is C low divided by C1. Remember, it is not F1 times F2 all the way to Fn. So basically, we're saying that you have different block, right? This is C1, C2, and after many blocks, eventually you have CL. This is Cn, right? This can be inverter, it can be a LAN gate, can be whatever, anything, okay? And we define this thing. Is this okay? And because of this, the minimum delay is equal to, again, right? I equal to 1 to n, TP0, and then PI plus HI divided by gamma, right? Because HI is GF, right? You still have the first term, which you cannot change and you don't care, right? I told you, you have a function. If this has to be AND gate, you have to put LAN gate. You cannot put inverter, right? So this term is always there. But the second term will become n times TP0 square root, nth root of capital H divided by gamma. Right? Is this okay? I know it's a lots of equation, but if you understand, this one should be straightforward to you to read. Any questions? Right, so memorize this, right? So it looks very simple, but now it's something very complicated. F. Remember, F, we always, this is the fan out of your circuit. You only look at the input and output, okay? But fan out is not necessarily equal to F1 all the way to Fn, right? Now, let me go back to here one more time. You see this one reduced to the inverter equation because Pi is equal to 1. If that is the case, this becomes n times P0, right? And then G is equal to 1. So this is just capital F. Okay. This is one. This is a definition. I forgot also to say we define H equals to G times F. So actually H is not no, we don't define. This is only true. I keep confusing you. So is only true if no branching. So what is the meaning of branching? I'm going to explain to you. Okay. So this one you remember. So maybe I should not write it. Maybe if you, because when you read to here, you will think that H equal to capital G times F, right? H equals to all the small G times F, but it's not capital G times F, right? This is equal to F1, G1, all the way to Fn, Gn, okay? Any questions so far? Now